Welcome to lecture number 3 on linear algebra. In previous lectures we have seen that given a linear system Ax equal to b, we associate the augmented matrix AB with this system. And then we reduce this matrix AB into an echelon form matrix. And with the echelon form of the matrix, we associate an invariant known as the rank. And with this matrix AB, we can associate two types of ranks. One is the rank of the overall matrix AB, and another one is the rank of the matrix A, which is a portion of AB. And hence, there are two possibilities. Number one, that rank of AB is greater than rank of A, and number two, the rank of AB is equal to rank of A. I consider the first case and we consider the following example. Rank of AB greater than rank of A. So we will have the following situation that here I have a matrix, here I have some entries, it is in echelon form, but at the end this is here I have an entry A which is different from 0, and on the left hand side I have all entries equal to 0. And in this case, the rank of AB is at least 1 greater than the rank of A, because we can see that there is a full row of zeros in A, whereas in AB this is not a zero row. And hence the rank of AB is at least greater than is at least 1 greater than the rank of AB. And hence from here we have an impossible situation, because if you observe this equation, this would mean that 0 is equal to A, which is a non-zero number, which is not possible, and hence in this case we will conclude that our system is inconsistent. The second possibility is that rank of AB is equal to rank of A, and the system in this case will be consistent. To investigate the system further, we have the following cases. Number one, we will define basic variables. So once we reduce a matrix into an echelon form matrix, we know about the pivot entries. So variables associated with pivot entries are termed as basic variables. For example, I have a matrix, I have a system Ax equals b, I have its augmented matrix, I reduce its augmented matrix into an echelon form matrix, and I have this matrix as the echelon matrix of this augmented matrix. Now we can see that there are only two pivot entries in this matrix. One is this one, another one is this one. And we know that this entry is associated with variable x1. This entry is associated with variable x3, and hence in this case x1 and x3 are my basic variables. For example, if I have another system, I have such a representation. This is a pivot entry, pivot, pivot and pivot. I have 4 variables in the system. This is corresponding to x1, x2, x3 and x4, and hence in this case x1, x2, x3 and x4 are basic variables. There are free variables. Variables in the system other than basic variables are called free variables. So once we separate basic variables, the remaining ones would be free variables. For example, I have a system Ax equal b, then I have its augmented matrix AB, I reduce it to an echelon form. This is the example that we considered earlier here. This is exactly this example. Then in this case, since I know that x1 and x3 are basic variables, hence x2 and x4 are my free variables. These are free variables. And if I consider this example, here I have once again 4 variables, x1, x2, x3 and x4. Since all the 4 variables are basic variables, hence this system has no free variable. So in example 2, there are no free variables. Thus I can summarize all this discussion in this following flow chart. I have a system Ax equals b. I consider the augmented matrix for this system, which is AB. I reduce that augmented matrix into an echelon form matrix, and I determine these two numbers, rank of AB and rank of A. If rank of AB is greater than rank of A, the system is inconsistent and hence we cannot proceed further. If rank of AB is equal to rank of A, the system is consistent. And we further need to investigate if the system is consistent, whether the system has a unique solution or infinitely many solutions. And if the system has unique or infinitely many solutions, how will we determine those solutions? So, if the system is consistent, I have to look at all the variables. If all the variables are basic variables, the system has a unique solution. And either we can reduce the matrix into a reduced echelon form matrix to have the direct solution, or it is equivalent to using backward substitution, which we will see in an example. And if there are free variables in the system will have infinitely many solutions. And once the system has infinitely many solutions, we will determine free and basic variables. And the next step that we need to perform is to express basic variables in terms of free variables so that we have infinitely many solutions for the system. So now we consider some examples using all these things. So the first example is this one. These are three planes in space. This is one plane, another plane, and another plane. And we want to know that whether all these three planes have a common point of intersection or not. So what I will do, I will consider the augmented matrix of this system. I considered it here. I put these dots here in order to separate these right hand side entries from those of the coefficients of these variables. And hence, if this entry must be 0 because we know that this is not in echelon form. So to make it 0, we subtract 5 times of this row from this row number 3. So it is recorded here. I have these entries. In the next step, I multiply row 2 with 1/2, row 3 with 1/10, and hence I have these entries. And if I perform one step more, I make this entry 0. So this can be made 0 with the help of this entry. So I subtract this row from this row. So row 3 minus row 2, and I have this form. And in the end, I divide row 3 by 1/3 to have this form. Now I see that this is in echelon form. The rank of AB, this overall matrix is AB. So this is non-zero, this is non-zero, this is a non-zero row, and hence the rank of AB is 3. Rank of A, just omit this portion, this rightmost column. So here in A I have 3 non-zero rows, hence the rank of A is 3. And hence rank of AB is equal to rank of A, which is 3, and hence the system is consistent. And now I note down the pivot positions. This is pivot entry, this is pivot entry, and this is pivot entry. This is corresponding to x1, this is corresponding to x2, and this one to x3. And hence all the variables are basic variables. And once all the variables are basic variables, the system has a unique solution. And how can we compute that? We use backward substitution. We start from this last equation. So from this last equation, we will have x3 equals -1 is here. From here, I will have x2 minus 4x3 equals 4. So I substitute the value of x3 to be -1, and hence I have x2 equals 0. And similarly, from this equation, I will have x1 minus 2x2 plus x3 equals 0. And if I substitute the value of x2 and x3, I will have x1 equals 1. So the solution of the system is given by 1, 0, 1. This is the unique solution of the system. I consider another example where I have inconsistency. So once again, I have 3 planes in space. I take its augmented matrix. I reduce it into an echelon form matrix. and I can note here that rank of AB is 3, but if I omit this portion, here rank of A is 2, and hence rank of AB is greater than rank of A, and hence the system is inconsistent, and which can be seen from this last equation that 0 is equal to 15 is nowhere possible. In this next example, we consider a system where we will have infinitely many solutions. So assume I have a system, and assume I have its augmented matrix reduced into an echelon form matrix as this one. So here this is in echelon form. Rank of AB, in AB we see that there are 2 non-zero rows, so 2. Rank of A, there are 2 non-zero rows in A, so once again this is 2, and hence rank of AB is equal to rank of A. The system is consistent. The next step is to identify pivot position. So we see that this is a pivot position, this is a pivot position. This is corresponding to x1, this is corresponding to x2, and hence my x1 and x2 are basic variables. Thus x3 and x4 are my free variables. And now to determine that the system has infinitely many solutions, how do we do that? We express basic variables in terms of free variables. So I start from this one. From this equation I have x2 minus 3x3 equals 6. So it produces what? It produces that x2 is equal to 6 plus 3 times x3. We see that x2 is basic, x3 is free variable, and in this representation x2 has been expressed in terms of free variable x3. And similarly from the first equation we will have x1 minus 4x2 plus 5x3 plus x4 equals 7. If I simplify it, I will have x1 equal to 31 plus 7x3 minus x4. So the solution is x1, x2, x3, x4. I have this representation. I separate this into the following form. So I have this representation for the solution set. And here I know that x3 and x4 are free variables, so they can assume any value. And now as you assign different values to x3 and x4, you have different solutions from this sum for the solution set of this system, and hence the system has infinitely many solutions. You can do so many things with systems. For example, I have a very general system, and now I want to determine the values on the right hand side so that the system is consistent. So the example is find an equation involving G, H and K that makes the augmented matrix correspond to a consistent system. So the idea is very simple. Reduce this augmented matrix to an echelon form matrix. I perform these two operations, G, H, and the last one is K plus 2G plus H, and from here for the system to be consistent, this entry must be 0. If this is different from 0, of course we have rank of AB greater than rank of A, which will make the system inconsistent, but we are looking for a consistent system, and hence for the system to be consistent this equation must be verified. And now just find values of K, G and H that satisfy this equation. You can put them here and they will make the system to be consistent. Thank you.